Welcome back to the deep dive. We know you are here because, well, you are a learner. You are curious. You want to stay ahead of the curve on global health trends, and you really want to understand the big structural shifts happening in the world.
Right, without feeling completely overwhelmed by just the sheer volume of information out there.
Exactly. And that is the goal here. We take the stacks of sources,
Mm.
the research, the policy papers, the medical journals, and we synthesize them into a clear picture of what is actually happening on the ground.
Yeah, we try to cut through the noise.
So today we are diving into a topic that, at first glance, it feels like the premise of a dystopian sci-fi novel. But as we will see from the data, it is a rapidly approaching reality.
Unfortunately, yes.
I want you to imagine a world where a simple paper cut from opening an envelope, or, say, a routine trip to the dentist to get a cavity filled, or even just a minor scrape from tripping on the sidewalk, carries a lethal risk.
It is an incredibly sobering scenario.
A world where the most mundane, everyday injuries could literally be a death sentence because our primary medical defenses simply do not work anymore.
Right, and that is the exact reality that public health officials, epidemiologists, and frontline medical professionals are actively bracing for right now.
As we transition into what is broadly being called the post-antibiotic era.
Exactly.
So our focus today is the escalating antimicrobial resistance crisis. You'll often hear this referred to as AMR. Now, full disclosure, the numbers we are going to look at are intimidating.
Very.
But I promise you, this is not going to be a lecture filled purely with doom and gloom.
Far from it, actually. While we have to understand the gravity of the biological threat, a major portion of our focus is going to be on the solutions.
Right.
Specifically, the innovative frontline triage systems being designed and deployed right now to prevent a complete collapse of our healthcare infrastructure. The way we handle healthcare at the community level is undergoing a massive, necessary evolution.
And to give you a sense of where we are pulling this from, our stack of sources today is incredibly diverse. We are looking at medical journal abstracts, extensive reports from the World Health Organization on global resistance tracking.
The WHO reports are very detailed on this.
Yeah, they really are. We also have hard data on the current pharmaceutical pipeline from groups like CARBX. And this is really interesting. We have transcripts from an Apple podcast series called Dr. Maya Beacon of Hope for Humanity.
Hosted by Dr. Kadiali Srivatsa.
Yes.
That specific podcast source is crucial because it helps us look at this crisis not just from the microscopic perspective of mutating bacteria, but from a psychological and behavioral perspective.
Which completely changes how you view the bottleneck in our medical system.
It really does. It's a complex web of biology, economics, and human psychology.
Our mission for this deep dive is to provide you, whether you're a healthcare professional, a policymaker navigating these systems, or just a highly informed citizen with a comprehensive, nuanced understanding of the AMR crisis.
And we want to explore how profound behavioral shifts, paired with AI-driven tools like the Prema kiosk, could serve as our ultimate frontline defense.
Okay, let's unpack this. I was looking through the WHO reports in our stack, and the data points are just staggering. I want to make sure I am interpreting this correctly. Can you lay out the baseline reality of where we are right now with antimicrobial resistance?
The baseline is moving very quickly. When we aggregate the data across these sources, we see that antimicrobial resistance is currently approaching approximately 42% worldwide.
Wow. So to put that in plain terms, almost half the time, the frontline drugs we rely on to kill bacterial infections are failing or showing significantly reduced efficacy.
That is the reality on a global scale, yes. But the more concerning aspect is the trajectory.
Right. Where is it heading?
The projections suggest an alarming climb to around 52% resistance by the year 2028.
Wait, 2028? That is right around the corner.
It is. We are talking about crossing the threshold where more than half of these infections are resistant. And the sources indicate that by 2028, treatment success in hospitals or clinics for these types of infections is projected to drop to a mere 40%.
A 40% success rate in a modern hospital setting. That feels like a massive regression. It feels like we are stepping back a century in terms of medical capability.
The human cost reflects that regression perfectly. Currently, AMR claims over 1.2 million lives directly each year across the globe.
And that is not a projection.
No, that is the current reality. But if the structural and behavioral issues driving this are not addressed, the projections hit 10 million deaths annually by 2050.
10 million.
To visualize that, you have to imagine the entire population of a major global metropolis, like London or Seoul, being wiped out every single year solely by infections we used to be able to manage with a simple course of pills.
That is, yeah, that is hard to even wrap your head around.
Mm.
But I was reading through these reports and I had this massive realization. I think I, and probably a lot of people listening, have a very narrow view of what antibiotics actually do.
How so?
Well, I always thought of them as the thing you take when you have strep throat or a bad ear infection. But the sources list medical procedures that I would not have immediately associated with antibiotics.
Ah, yes, the foundational role of these drugs.
Exactly. The list includes cesarean sections, joint replacement surgeries, transplant surgeries, chemotherapy, intensive care medicine, and major wound and trauma care.
Yeah.
Am I understanding this right? Without effective antibiotics, these incredibly routine procedures become potentially lethal.
You are understanding it perfectly. And it is a fundamental shift in how we need to view modern medicine. Antibiotics are not just treatments for when you get sick. They are the invisible, foundational safety net that allows modern medicine to exist.
Okay, break that down for me.
If you look at that list of procedures, they share common risk factors. They either involve deliberately breaking the skin, which is the body's primary physical fortress against pathogens, or they involve intentionally suppressing the patient's immune system.
Let's take a joint replacement, for example. My uncle just had his knee replaced. It is considered a totally standard quality of life procedure now.
It is standard because we have the safety net. In a joint replacement, surgeons are cutting deep into tissue and implanting a foreign piece of hardware, metal, and plastic into the human body.
Right.
Bacteria love to adhere to those foreign surfaces. If a single superbug is introduced during that surgery and we do not have an effective antibiotic to clear it out, that routine surgery can lead to an unstoppable bone infection, amputation, or sepsis.
Wow. So the entire risk-benefit calculation of the surgery collapses.
Completely collapses.
And it is the same logic for chemotherapy or organ transplants, right?
Yeah.
To give someone a new kidney, you have to chemically suppress their immune system so their body does not attack the new organ.
Yes. And while their immune system is suppressed, they are entirely reliant on prophylactic antibiotics to keep opportunistic bacteria at bay. If the antibiotics fail, the bacteria, which are everywhere in our environment and even naturally in our bodies, will overwhelm them.
And the same applies to intensive care medicine, I assume.
Absolutely. Patients on ventilators or with central intravenous lines have direct pathways for bacteria to bypass their natural defenses. Without antibiotics, ICUs cannot function safely.
So the natural question you are probably asking right now as you listen to this is, why do we not just make new antibiotics? We have brilliant scientists, we map the human genome, we have massive multi-billion-dollar pharmaceutical companies.
Let's just invent our way out of this.
Right, let's just invent our way out of it. But the stack of sources, particularly the data from the WHO and CRB, highlights a really terrifying reality about the pharmaceutical pipeline. It is incredibly dry.
It is remarkably thin. CARBX, for context, is the Combating Antibiotic-Resistant Bacteria Biopharmaceutical Accelerator. They track the clinical development of these drugs globally.
And what do their numbers say?
Their data shows that out of 97 agents currently in clinical development worldwide, only 12 are considered truly innovative. And of those 12, only 4 target what the WHO classifies as critical priority pathogens.
The sources mention Acinetobacter baumannii, specifically the carbapenem-resistant strains. These are the bugs that keep hospital administrators up at night.
They are absolute nightmare pathogens because they have evolved mechanisms to neutralize almost every class of drug we throw at them, including carbapenems, which were traditionally our last resort antibiotics.
And we only have 4 innovative agents globally targeting that entire critical priority list.
Yes. It is a severe vulnerability. We are basically bringing a handful of prototype shields to a massive, evolving biological war.
This leads to this bizarre, almost tragic economic paradox that the sources detail. I found this to be one of the most frustrating parts of the research.
The market failure aspect.
Yeah. Creating a new drug is wildly expensive. We are talking hundreds of millions of dollars, sometimes over $1 billion, and years of clinical trials. Normally, a pharmaceutical company recoups that massive investment by marketing and selling the drug to as many patients as possible.
That is the standard business model for blood pressure medication, cholesterol drugs, or antidepressants. You want high volume.
But with a brand new, highly effective antibiotic, the rules completely flip. Public health protocols dictate that we absolutely cannot sell it widely. We have to take this billion-dollar innovation, lock it in a metaphorical glass box, and put a sign on it that says, break glass only in case of absolute emergency.
Right. We have to use it incredibly sparingly to prevent the bacteria from getting exposed to it, mutating, and developing resistance to this new weapon.
And from a business perspective, it is a complete disaster. It completely decouples revenue from development. You spend $1 billion making a vital drug, and the global health authorities tell doctors, do not prescribe this unless you have exhausted every other option and the patient is going to die.
From a biological stewardship perspective, that is the only responsible action. You must preserve the efficacy of the new chemical weapon for as long as biologically possible. If you prescribe it for every minor infection, the bacteria will learn to defeat it within a few years.
I get that. But for the pharmaceutical companies, succeeding in developing a new antibiotic often equates to financial bankruptcy. The financial incentive structure to solve this problem is completely broken.
It is a profound market failure, but it is also where the narrative takes a really crucial turn in our sources.
Okay.
The biological mutation of bacteria is a massive, complex problem. The broken economic model for drug development is a massive problem. But Dr. Srivatsa's podcast Insights argue something really compelling.
What is that?
The true underlying driver that is accelerating this crisis is not just biology or economics, it is human psychology.
You know, I am totally guilty of this. Last winter, I had a cough that lingered for weeks. I was exhausted, I felt awful, and I swear I convinced myself it was developing into pneumonia. I basically went to my doctor and begged for a Z-Pack. I did not want a diagnosis, I wanted the medicine.
You are definitely not alone in that reaction.
Looking at this data, I was the exact worried, patient causing this systemic bottleneck.
And the source material delves deeply into why we do that. To understand why we are depleting our arsenal of effective antibiotics so rapidly, we have to look at how the human brain processes the threat of illness.
The psychology of fear.
Exactly. Neuroscience demonstrates that the human brain, specifically the more primitive parts of it, cannot easily distinguish between a real, imminent physical danger and an intensely imagined fear.
The sources talk about the amygdala, right? The part of the brain responsible for processing fear and triggering that raw fight-or-flight response.
Yes.
Yeah.
It activates almost instantaneously, long before our rational, logical prefrontal cortex gets a chance to evaluate the evidence and say, hey, it is just a common cold.
So when that amygdala fires up, because a patient is imagining the worst-case scenario, say they have a minor cough, but their anxiety spirals into fears of severe, life-threatening respiratory failure, their body does not know the difference.
It experiences a very real systemic physiological impact. Their heart rate elevates, their breathing becomes labored and shallow, their body temperature can fluctuate. They might experience cold sweats, dizziness, or even abdominal pain simply from the panic.
So their physical body is reacting as if a tiger is in the room, or in this case, a lethal infection. And the sources note that chronic or intense stress triggers the release of stress hormones.
This is heavily relying on cortisol and adrenaline.
And here's the really insidious part. Chronic exposure to high levels of cortisol actively suppresses the immune system. It inhibits the production of white blood cells. So by being intensely afraid of getting sick, a patient is biologically making themselves more vulnerable to the very infections they are terrified of.
It is a vicious, self-fulfilling physiological loop, and this internal biological state translates directly into external, real-world patient behavior.
They seek medical help.
In droves. Not necessarily because they are presenting with a serious life-threatening disease, but because they are being driven by this amplified, unmanaged fear. They are seeking a psychological intervention as much as a medical one. They want the fear to stop.
And sources detail exactly what those presentations look like. What are the symptoms these fear-driven patients are bringing into clinics and emergency rooms?
It is incredibly common stuff. A persistent cough, a mild fever, a scratchy sore throat, minor scrapes or wounds that look a little red, and basic stomach upset or nausea.
The critical point here is that the vast majority of these specific illnesses are entirely self-limiting, or they are viral in nature.
Right. A bacterial antibiotic will do absolutely nothing to cure a viral sore throat. The antibiotic targets bacterial cell walls or metabolic processes. A virus does not have those structures.
But patients, driven by that amygdala response and seeking a tangible physical cure for their anxiety, frequently expect antibiotics.
In many cases, they aggressively demand them. They view the prescription pad not as a specific chemical tool, but as a psychological safety blanket.
If we zoom out, we can see how this creates a massive systemic domino effect. Imagine this interaction happening tens of thousands of times a day across every city and town. It creates immense, crushing pressure on the frontline workers.
The pharmacists, the family doctors, the staff at local urgent care clinics, they are drowning in fear-driven demand.
And the data on healthcare utilization reflects this perfectly, doesn't it?
It does. Studies cited in our material estimate that in the United States, between 30 and 40% of all emergency department visits are non-urgent. They are cases that absolutely do not require emergency level intervention.
30 to 40%. That is a massive chunk of emergency resources.
And similarly, in the UK, NHS analyses have demonstrated that up to one-third of all hospital visits could be safely and effectively managed entirely outside of the hospital setting.
So you have a healthcare system that is essentially flooded with the worried, well, or at least the mildly ill but highly anxious. And once a patient is inside that healthcare system, sitting in an examination room, a whole new dynamic takes over.
Yes.
Doctors are forced into practicing what the sources call defensive medicine. Let's unpack that, because it is a huge piece of the puzzle.
Defensive medicine is a massive driver of antibiotic misuse. Consider the doctor's position. They have a patient in front of them who is highly anxious and demanding a solution. The doctor's clinical judgment might strongly suspect it is just a viral upper respiratory infection.
But there's always a tiny margin of uncertainty.
Always. And to protect themselves legally to avoid that 1 in a million malpractice lawsuit if the patient goes home, deteriorates, and it turns out to be a rare bacterial presentation the doctor over-investigates.
They order blood tests that aren't strictly necessary. They document excessively to cover their liability. And most importantly for the AMR crisis, they prescribe unnecessary antibiotics just in case.
The doctor knows it is likely viral, but the systemic medico-legal pressure, combined with the patient's demand, makes it easier to just write the script. The intention is often protect the patient, protect the medical license, but the aggregate result is a completely overloaded system and a massive acceleration of bacterial resistance.
And here is where this fear-driven behavior goes from being a systemic annoyance, wasting time and money, to a deadly public health failure. Rushing to the hospital out of fear does not just waste resources. The sources emphasize that it actually puts the patient in profound physical danger.
It is a huge risk.
There's a statistic from the material regarding hospitals in India that literally made me stop reading. It noted that in some Indian hospitals, up to 83% of people are colonized with AMR bacteria. And that does not just mean the sick patients in the ICU.
No, that 83% figure includes everyone in the environment. It includes the doctors, the nurses, the administrative staff, and the cleaning crews.
Just to clarify, colonized means what exactly?
Colonized means that these highly resistant superbugs are living and multiplying on their skin, in their respiratory tracts, or in their nasal passages. The person might not be actively sick with a systemic infection at that moment, but they are a carrier of the resistant bacteria.
That is terrifying.
And globally, the World Health Organization estimates that between 7 and 10% of all hospitalized patients will acquire a healthcare-associated infection, or HAI, during their stay.
So let's play out this scenario. You have a viral cough. You are scared. Your amygdala is firing. Your cortisol is elevated. You bypass resting at home and you rush to a crowded hospital emergency room.
A classic fear response.
You sit in the waiting area for 6 hours. You are touching the armrests. You are breathing the recirculated air. You are interacting with triage nurses and doctors who are constantly exposed to severe resistant illnesses. You are bringing your own suppressed immune system, thanks to your stress and fear, into an environment that is quite literally a centralized breeding ground for the most dangerous, drug-resistant superbugs on the planet.
It is the absolute worst place you could be for a minor viral illness. This is why the sources draw the conclusion that fear acts as a public health multiplier.
When fear drives unnecessary hospital visits, the population's exposure to superbugs increases exponentially. Unnecessary antibiotic prescribing rises due to defensive medicine. The obsolescence of our limited chemical weapons accelerates.
And it is crucial to note that the people who suffer the most in this overloaded system are often the most vulnerable populations.
Right. Those facing poverty, systemic language barriers, and limited access to primary or follow-up care who rely on the emergency room as their only point of access.
Exactly.
So if doctors are trapped by liability in defensive medicine and hospitals are active breeding grounds for superbugs, who actually acts as the pressure valve here? Who is the real gatekeeper trying to hold back this flood of anxious patients?
The true first line of healthcare, long before a patient ever navigates the complexities of booking a doctor's appointment or sitting in a hospital waiting room, is usually the local pharmacy or chemist.
That tracks perfectly with human behavior. If I wake up with a scratchy throat, I do not instantly drive to the ER. I walk down to the pharmacy on the corner to look for cough syrup or lozenges, and I ask the pharmacist behind the counter what they think I should take.
And that incredibly common interaction places an absolutely immense burden on pharmacists. They have become the de facto primary gatekeepers for the entire healthcare system.
And they face a remarkably difficult, incredibly high-stakes diagnostic challenge every single day, often with very limited resources.
Let's walk through what that challenge actually looks like on the ground. A person walks in from the street, coughing, looking anxious, maybe a little flush. The pharmacist is standing behind a busy counter.
They don't have a chart, they haven't run blood work, they don't have an hour to take a full medical history.
In that moment, they have to quickly distinguish whether this is a minor, self-limiting viral illness that just needs time, or if it is the subtle, early warning sign of a severe underlying bacterial infection or a true medical emergency.
They are forced to make rapid, split-second clinical judgments based on brief interactions.
Yeah. Yes. They have to decide when simple reassurance and over-the-counter symptom relief are sufficient, versus when they must urgently tell the patient, do not buy this cough syrup, you need to go to an urgent care clinic immediately.
And above all, as the ultimate gatekeepers of the medication supply, they must actively avoid inappropriate antibiotic dispensing. They are standing as the literal dam against the flood of public demand we just spent so much time discussing.
And they are absorbing an intense amount of clinical risk to do this.
The sources provide a really interesting historical context from the UK that highlights the intense friction surrounding this role. Around 2006, the UK government initiated a major policy shift.
The extended formulary.
Right. They granted extended formulary and independent prescribing powers to nurses and pharmacists. The stated goal was to ease the massive, unsustainable workloads on general practitioners and give patients faster, easier access to medicines in their communities.
It was a very significant structural change, and the source material details the intense professional conflict it caused. It is important we look at both sides of this impartially.
Of course. So on one side of the debate, you had the British Medical Association, the BMA, which represents doctors. They strongly opposed the move. The BMA leadership at the time publicly called it an irresponsible and dangerous move.
Their argument was deeply rooted in diagnostic training. The BMA argued that only doctors possess the 5 to 6 years of rigorous, specialized medical school training required to safely and accurately diagnose disease across all possible conditions.
Their concern was that granting prescribing power to pharmacists and nurses who have different training backgrounds raised serious patient safety issues, particularly regarding misdiagnosis.
Conversely, government officials, including the chief nursing officer at the time, countered that argument strongly.
They emphasized that nurses and pharmacists undergo rigorous, specific, and specialized training programs before ever being allowed to prescribe independently.
Right. They argued that these professionals are trained to recognize their own clinical boundaries and would only prescribe within their specific area of established expertise.
Ultimately ensuring that patients receive safe, fast, and convenient care without bottlenecking the doctor's offices.
Exactly. But regardless of how that specific policy debate settled out over the years, the overarching takeaway from our sources is undeniable. The intense clinical risk that pharmacists absorb on the front line is immense.
If a pharmacist gives incorrect advice over the counter, or if they miss a subtle early indicator of something lethal like sepsis,
Or if they dispense an unsuitable medication because they were worn down by an aggressively fearful patient.
the legal, professional, and moral consequences for that pharmacist are utterly devastating.
They are operating in a high-stakes, high-pressure environment, catching the full, unfiltered force of the public's health anxiety, often without the safety net of comprehensive diagnostic tools or the broader legal protections traditionally afforded to physicians.
Let's summarize the board as it stands. We have a biological crisis in the form of rapidly mutating bacteria. We have a broken economic model that has stalled the development of new drugs. We have a psychological crisis of unmanaged fear driving people to seek unnecessary care and demand antibiotics.
And we have pharmacists bearing the brunt of this immense pressure at the front line, trying to hold the line without adequate support.
This is a system perfectly primed for structural collapse.
Which brings us to the technological intervention highlighted in our sources. If human fear and behavioral psychology are the massive engines driving the misuse of antibiotics and the overloading of the system, we need a solution that specifically addresses that human element at the very front door of healthcare.
We need a circuit breaker.
Exactly.
Wait, let me play devil's advocate for the listener here. You are telling me the solution to a global biological crisis, A dry pharmaceutical pipeline and failing hospital systems is an AI kiosk sitting in a pharmacy. Isn't that just another version of WebMD or a symptom checker app? Because every time I type my symptoms into one of those, it tells me I have 3 days to live, which just makes my amygdala fire even more.
That is exactly the distinction the sources make. This is not a standard symptom checker. The intervention discussed is the Prema system. Prema stands for Personal Risk Evaluation and Mental Assurance.
The name itself is the key.
It is. It is explicitly designed to evaluate risk, but equally designed to provide mental assurance. It manages the fear before the fear becomes harmful behavior.
I really want to dig into how it actually works because the sources differentiate it heavily from traditional algorithms. They talk about Maya symptom pattern reasoning. How does Maya reasoning differ from the rigid decision trees we are used to interacting with online?
Think about how those traditional algorithms work. They are essentially rigid yes or no flowcharts built by lawyers as much as by doctors. They are notoriously risk averse.
If you check the box for headache and stiff neck, the rigid algorithm immediately routes you to go to the emergency room for meningitis.
Because the liability of missing meningitis is too high for the software developer, they inherently over-triage. They feed directly into the defensive medicine loop, ultimately increasing hospital visits and escalating patient anxiety.
Right, they act like a panicked patient.
Right.
But Maya's symptom pattern reasoning is designed to mimic the nuanced, contextual thought process of a seasoned, experienced human doctor.
Exactly. A seasoned physician does not look at one symptom in isolation on a checklist. They look at the pattern, the history, the context, and how symptoms group together.
So it's not just a binary yes or no.
No. Maya reasoning assesses combinations of symptoms, often grouping them in threes, using a sophisticated color-coded assessment system. It understands that a cough, a low-grade fever, and a runny nose together tell a very different story than a cough, a high fever, and sudden chest pain.
By analyzing these specific symptom combinations and patterns, the Prema system aims to quickly and accurately categorize the patient's condition into one of 4 distinct lanes. And these lanes are crucial for triage.
Let's go through them. Lane 1 is a minor illness requiring no formal medical intervention. Essentially, go home, drink water, take a lozenge.
Lane 2 is a moderate health issue that might need monitoring or a non-urgent pharmacy consultation.
Lane 3 is a potential infection that actually requires a doctor's evaluation.
And Lane 4 is a genuine emergency requiring immediate hospital care.
Now, visualize the impact this could have on the entire healthcare pipeline if deployed correctly. If you place these Prema kiosks at the absolute front door of healthcare, physically located inside community pharmacies, or accessible as a trusted community tool, you are actively addressing the root of the behavioral crisis.
So a patient walks into the pharmacy with a viral sore throat and a mild fever. Their amygdala is firing, they are scared, they are ready to demand an antibiotic. But instead of spiraling into panic or arguing with the pharmacist, they interact with the Prema system.
And the Maya reasoning analyzes their symptom cluster and provides authoritative, AI-driven reassurance that their symptoms fall firmly into the minor illness category.
The intervention is the reassurance. The fear is mitigated objectively. And because the fear is mitigated, the demand for the antibiotic is cut off at the source before the patient ever sees a doctor or pressures the pharmacist.
And the domino effect reverses. It drastically reduces unnecessary antibiotic use in the community. It eases the crushing daily pressure on both pharmacists and doctors by effectively filtering out the non-urgent cases before they ever consume a professional's limited time.
It guides people toward the appropriate level of care based on logic, not panic.
Most importantly, it keeps healthy or mildly ill people out of the hospitals. It prevents them from unnecessarily exposing themselves to those highly colonized, high-risk environments in emergency rooms where hospital-acquired superbugs thrive.
It acts as a shield, keeping the worried well safe from the truly sick.
As we look to the future, as we stare down the barrel of that 52% resistance projection by 2028, it becomes clear that community triage systems like Prema are no longer just nice-to-have tech innovations.
They aren't just cool gadgets for a pharmacy to show off.
They're absolute systemic necessities. If the antibiotic pipeline remains as thin as it is today, and the economic realities strongly suggest it will, our entire global model of healthcare must undergo a paradigm shift.
We can no longer rely on a system designed primarily to treat infections after they occur, because the chemical treatments we rely on are failing. We must shift proactively to a model of hypervigilant prevention, early isolation, and incredibly precise early triage. I want to paint a picture of what this near future looks like based on the sources. Imagine local pharmacies evolving into the ultimate community health gatekeepers, structurally equipped with these advanced AI triage tools. The benefits discussed in the material are massive and multi-layered.
First, it fundamentally protects the pharmacists. By providing a data-driven, objective, Maya-reasoned backup to their clinical decisions, it significantly reduces their personal, clinical, and legal risk.
If a patient is demanding an antibiotic, the pharmacist is not just relying on their personal authority. They can point to the Prema evaluation as an authoritative, objective standard of care.
Secondly, it empowers the public in a really profound way. The sources talk about restoring body literacy.
Body literacy.
Yes. For decades, we have been conditioned to be entirely dependent on doctors for every minor ache, pain, or sniffle. Community triage tools help people learn to understand their own symptoms again. They learn to conquer their health anxieties through knowledge and accurate, objective assessment, rather than relying on an immediate chemical intervention to soothe their fear.
The system is also designed to catch serious illness earlier than a layperson might. The sources mention a specific, fascinating pattern recognized by Maya reasoning: cold skin in early sepsis.
This is a perfect example of its capability. A layperson or an anxious parent might only be looking for a raging high fever as a sign of severe infection. But the Maya symptom pattern reasoning is trained to catch subtle, counterintuitive combinations like a normal temperature, but unusually cold skin and rapid breathing that indicate severe systemic infection before the patient crashes.
And if we look at this from a macro epidemiological perspective, widespread community triage dramatically improves public health awareness.
Imagine if multiple Prema kiosks in a specific neighborhood or zip code start registering high levels of a specific symptom cluster, say, severe gastrointestinal issues.
Public health officials can identify localized outbreaks of infections in real time before they escalate into hospital-wide epidemics. It provides community-level, real-time syndromic surveillance.
This shift represents something much deeper than just adopting new technology. Dr. Srivatsa's podcast brings in a broader global health philosophy mentioned in the sources, the concept of ahimsa.
Ahimsa is a profound philosophical principle. It translates roughly from Sanskrit to nonviolence, or more accurately in this context, non-domination or doing no harm.
In the context of global public health, applying ahimsa means deliberately moving away from a traditional doctor-centered, heavily profit-driven model. It means moving away from a systemic structure that, however unintentionally, ends up exploiting patient fear to drive high utilization and revenue.
Instead, it is about moving toward a system that deeply respects the human body's inherent resilience. It is about empowering the patient, restoring their free will and agency regarding their health, and building structural resilience within communities.
It is a shift away from relying solely on failing chemical weapons, which, if we are being honest, is exactly what antibiotics are. They are chemical weapons deployed against bacteria.
That is the ultimate conclusion we must draw from synthesizing this material. As we enter the post-antibiotic era, we cannot simply sit back and rely on the hope of a miracle drug being discovered in time.
Biology is outpacing pharmacology. We have to adapt our societies and our behaviors. Community-level early assessment tools, profound behavioral shifts regarding fear, and intelligent triage are how modern civilizations will build the necessary structural resilience to survive this crisis.
So what does this all mean for you, listening right now? Let's bring this right back to your life and your daily choices. We have gone from the terrifying math of the AMR crisis, approaching that 52% resistance mark, to the deep neuroscience and psychology of fear that drives us to misuse vital medicines.
We have seen the impossible high-stakes burden placed on our local pharmacists, and we have explored the brilliant symptom pattern logic of systems like the Prema kiosk.
The next time you wake up with a mild fever, or a scratchy sore throat, or a lingering cough, I want you to remember this deep dive. Understanding the difference between a real medical emergency and the physical sensation amplified by your own amygdala and fear will not just save you a frustrating, potentially expensive trip to the clinic.
It is a conscious, vital act of public service.
By managing your fear, resting, and not demanding an unnecessary antibiotic from your doctor or pharmacist, you are actively helping to preserve the efficacy of modern medicine for everyone. You're holding the line.
I will leave you with a final, provocative thought drawn from the historical context in our sources. Civilizations rarely fall because of one explosive battle or a single cataclysmic event. They erode gradually when their internal foundational systems can no longer protect their people.
As we learned from the Peloponnesian War, The slow fall of the Roman Empire and the catastrophic spread of the Spanish flu following World War I. When societal infrastructure weakens, microbes advance.
Biology never negotiates. It only exploits vulnerability. So the question we must ask ourselves as we look at our own infrastructure is this. Are our current fear-driven healthcare systems strengthening life and resilience? Or is our overutilization actively inviting our own decline?
That is definitely something to mull over the next time you reach for the medicine cabinet out of panic. Stay curious, stay informed, and we will see you on the next deep dive. Imagine a world where a simple scratch, a minor surgery, or a routine dental visit carries a lethal risk. We are rapidly approaching the post-antibiotic era. Currently, antimicrobial resistance is nearing 42% worldwide. By 2028, projections warn that resistance could hit 52%. If that happens, the foundational miracles of modern medicine, cesarean sections, joint replacements, chemotherapy, and trauma care become incredibly dangerous. The invisible safety net of antibiotics is fraying.
But the root of this crisis is not just mutating bacteria. It is human behavior. Driven by fear, patients flood clinics and emergency rooms for minor, self-limiting viral symptoms, coughs, sore throats, mild fevers. They demand antibiotics for peace of mind. This places an impossible burden on our frontline healthcare workers, particularly pharmacists, who must distinguish between a harmless cold and a lethal infection, all while absorbing immense clinical risk and facing patient pressure.
This fear-driven cycle overloads hospitals, turning them into high-risk transmission zones for superbugs, and accelerates the obsolescence of our drugs. We cannot simply invent our way out of this with new pills. The pharmaceutical pipeline is dangerously dry.
The solution lies in behavioral shifts and intelligent community triage. Enter systems like the Prema kiosk, personal risk evaluation, and mental assurance. Using advanced symptom pattern reasoning, Prema acts as an AI-empowered gatekeeper at the pharmacy level. It does not just check symptoms, it manages fear.
By quickly categorizing symptoms into minor, moderate potential infection or emergency, Prema reassures the anxious, protects pharmacists from clinical risk, and crucially stops unnecessary antibiotic prescriptions at the front door. As we face the reality of the AMR crisis, equipping our communities with these intelligent triage tools is not just an upgrade to healthcare, it is the essential defense line for the survival of modern medicine.